So here we have our given example, dy over dx is equals to 2e raised to x minus 0.5y, where our y of 0 is equals to 0, and we will find the value for y of 2 at h, or our step size, is equals to 1 using Heun's method. So here is our general formula for Heun's method. Y sub I plus 1 is equals to y sub I plus 1 over 2 k sub 1 plus 1 over 2 k sub 2 multiplied by h, or our step size. So for finding the k sub 1, we have here formula function of x sub I and y sub I, and for k sub 2 we have function of x sub I plus h and y sub I plus k sub 1 multiplied by h. So since we don't have any given value for I, so we will assume our I here is equals to 0 if our x sub 0 is equals to 0 and our y sub 0 is equals to 0. This is our initial values for us to get the value for y sub 1 first. So first we will get the value for k sub 1. We have k sub 1 is equals to function of x sub I, which is our I is equals to 0, so function of x sub 0 and y sub 0. So our x sub 0 is 0 and our y sub 0 is 0. We have function of 0 and 0. So by substituting these values here in our given function, so we have 2e raised to 0 minus 0.5 multiplied by 0, so this is cancelled, so we will get 2. So this is our value for k sub 1 at I is equals to 0. So next we will get the value for k sub 2. So we have here the formula k sub 2 is equals to function of x sub I, which is our I is 0, so we have x sub 0 plus h and y sub 0 plus k sub 1 multiplied by h. So again, our value for x sub 0 is 0 and our y sub 0 is 0. And now we have our value for k sub 1, so we can get the value for k sub 2. So we have function of 0 plus 1 0 plus our k is 2 multiplied by 1, so we have function of 1 and 2. So by substituting the value for x and y, we have 2e raised to 1 minus 0.5 multiplied by 2, so we will get 4.4366. So this is our k2. So since we have our values for k sub 1 and k sub 2, so we can now get the value for y sub 1. So our y sub 1 is equals to y sub 0 plus 1/2 k sub 1 plus 1/2 k sub 2 multiplied by h. So by substituting the values, we have y sub 0 is 0 plus 1/2 k sub 1 is equals to 2 plus 1 half k sub 2 is 4.4366 multiplied by h, so this is cancelled. So our y sub 1 is equals to 3.2183. So for calculating the value for x sub 1, we have this formula x sub 0 plus h, which is 0 plus 1. So our x sub 1 is equals to 1. So now, since we have our values for x sub 1, y sub 1, so we can proceed to the next procedure, where our I is equals to 1, our x sub 1 is equals to 1, and our y sub 1 is equals to 3.2183, and our h, our step size, is equals to 1. So now again, we will first calculate the value for k sub 1. We have k sub 1 is equals to function of x sub 1 and y sub 1. So our x sub 1 is 1 and our y sub 1 is 3.2183. So we have function of 1 and 3.2183. So we're substituting these values of x and y. We have 2e raised to 1 minus 0.5 multiplied by 3.2183. So by calculating, we will get 3.8274 for our k1. And for our k2, since we have our value for k1, so we can calculate the value for k sub 2. So our k sub 2 equals to function of x sub 1 plus h and y sub 1 plus k sub 1 multiplied by h. We have function of x sub 1 is 1 plus our step size is 1. Our y sub 1 is 3.2183 plus k sub 1. Our k sub 1 is 3.8274 multiplied by step size is 1. So by calculating this, we have function of 2 and 7.0457. So by substituting this value of x and y, we have 2e raised to 2 minus 0.5 multiplied by 7.0457. So by calculating this, we will get our value for k sub 2, which is 11.2553. So now, since we have our values for y sub 1, k sub 1, and k sub 2, so we can get the value for y sub 2. So using this formula, by substituting these values, so we will get 3.2183 plus 1 half k sub 1, which is 3.8274 plus 1 half 11.2553 multiplied by h, which is 1. So by calculating this, we will get 10.7597. and this value is our y of 2. That's it. Thank you.